In this lecture, we will discuss continuous and discrete time signals. We can broadly classify signals into two types. The first one is the continuous time signals and the second one is the discrete time signals. So let us start our discussion with the continuous time signals. The signals which are specified for every value of time t are called continuous time signals. That is, in continuous time signals, we can define the signal at any interval of time, and a continuous time signal is represented by small x within the parenthesis small t. Here small x is the dependent variable and small t is the independent variable, and we can see that this small xt is a single variable signal because we are having only one variable, and that is the time t. So let us consider some examples of continuous time signals. These are examples of continuous time signals. Now in continuous time signal, the y-axis is always for the function or the signal and the x-axis is always for the independent variable. So xt is the signal, so it has been plotted along the y-axis, and t is the independent variable, so it has been plotted along the x-axis. So this is t, this is minus t. Here also we find this is t, this is minus t, this is t, and this is minus t. Now when we observe this signal, we find that this signal xt is having a value of a at t0, and the value of this signal becomes 0 at t2. Similarly, the value of this signal also becomes 0 at minus t2, and it remains 0 thereafter this side also, and here also we find that this remains 0 after minus t2, and this value remains 0 up to plus infinity. Similarly, this side also it remains 0 up to minus infinity. Now this is our continuous time signal. We are calling it as continuous time signal because if we see this signal, then we find that this system can be defined or it is specified for every value of time t. We can find out the value of this signal xt for every value of time t from minus infinity to plus infinity. Similarly, if we observe this sine wave and this triangular wave, we find that we can find the value of this sine wave and this triangular wave at any time t. Suppose we want to find the value of this function xt at t is equal to 0.5, t is equal to 0.7, at t is equal to 2.4, 3.7, then we can easily find the value of this signal by just drawing a perpendicular to the x-axis and finding its value on the y-axis. So we say that these signals are continuous time signals. Now let us come to the discrete time signals. The discrete time signals are the signals which are specified only at discrete time intervals, or we can say that they are specified only at discrete values of time. We can define these signals only at discrete intervals of time. So we cannot find the value of these signals at every interval of time, and in short we write the discrete time signals as DTS. And a discrete time signal is represented by small x within the square bracket small n. This small n is not time, but it is an integer. So this is the difference between the continuous time signal and the discrete time signals. That is, in discrete time signal we have square bracket in place of parenthesis, and in discrete time signal we have integer in place of time. So here the dependent variable is x and the independent variable is small n. Now we will plot the discrete time signal using the definition of the continuous time signal, and from the definition of discrete time interval it is we have seen that discrete time signal is specified at discrete time intervals. It is not specified for every value of time t, but it is specified only at discrete time intervals. Now let us say that this signal xt is specified at t0 and the value of this signal at t0 is a. It is also specified at t1 and the value of this signal at t1 is equal to this value. Similarly, it is also specified at t2 and the value of this signal at t2 is 0. Similarly, it is also specified at minus t1 and at minus t1 the value is equal to this much. Similarly, it is also specified at minus t2. Now it is also specified at minus t3 plus t3, that its value is 0. It is also specified at minus t3 and so on this side and so on this side. So we can see that the signal is not specified at every value of time. Suppose we want to find out the value of this signal xt between time t1 and t0, then we cannot find its value because it is not defined. So we can draw the plot of the discrete time signal in which the signal is defined only at discrete values of time. So this is the plot which we will get from the continuous time signal. This is an example of the discrete time signal, because here if we want to find out the value of xt between t0 and t1, then we cannot find its value because this is not defined at discrete intervals of time. So we discretize the time axis. Here y axis for xn and the x axis is for t. Now at t0 we find that the value of the signal is a. At t1 the value of the signal is equal to this value, and at t3 we find that the value is 0 again. Now at minus t1 this value is equal to this much. So we have plotted here this value. Similarly, the value at minus t2 is again 0. So this is again 0. So this is the plot of discrete time signals. Let us suppose that the time interval between two these is equal to delta t. Then delta t will be equal to t1 minus t0, that will be equal to t2 minus t1 is also delta t, t3 minus t2 is also delta t. Similarly, tn minus 1 is also equal to delta t. Now this delta t can be equal for in each case, or it may be not equal. Suppose the delta t is equal to in each case, then in that case we will get the value of delta t will be equal to t1 minus t0, that will be equal to t2 minus t1, that will be equal to t3 minus t2 and so on. If the time interval is the same in each case, then we can say that this discrete time signal is uniformly sampled. And when the time interval is not the same in each case, then this signal is non-uniformly sampled. Now we will discuss one very important thing, that is the existence of this integer n here. Now we see that this x-axis is for time, then how we got the integer as the independent variable. Now let us consider the case of uniformly sampled signals. So in this case we find that when the signal is uniformly sampled, then it means that delta t will be the same in each case, and let us suppose that the value of delta t is equal to capital T. So the value of t1 minus t0 will be equal to capital T. So t minus 0 will be equal to t. Similarly, t1 minus t0 will also be equal to t, that will be equal to t2 minus t1, that will be equal to t3 minus t1. And when this happens, then Tn minus 1 will also be equal to capital T. And let us say that this T0 is equal to 0. So in this case T1 minus 0 will be equal to capital T. So we can write this as capital T, we can write this as 2t, we can write this as 3t and so on, and we can write this as nt. Now when we are having t as the independent variable, then we cannot write xn, so we will write it as xnt. Now we will cancel t on this side and this side both. So these t cancels out and we get the values at 0, 1, 2, 3, 4 up to n. And here also it cancels out, so it is xn. So we find that here we are having the integer values like 0, 1, 2, 3, 4 up to n. So this is how we write the discrete time signals as xn, and we plot n along the x-axis. Now this is also an example of discrete time signal which has been obtained from this sine wave. That is, we have taken the plot at here this time, this time, this time and this time. So we will get a wave like this. So this is the difference between continuous time signal and the discrete time signals. Hope this topic is clear to all of you. So see you in the next presentation.